Welcome to the Mind Spark, your source for breaking news and trending stories from around the world. The news broke not with a bang, but with a flicker. On June 15, 2025, the James Webb Space Telescope caught something extraordinary from Proxima b, our closest exoplanetary neighbor. Scientists expected subtle hints of an atmosphere, maybe a barren rock. Instead, they saw a rhythmic, impossibly precise pulse of light from the planet's terminator, the line between day and night. It wasn't random, it wasn't natural, it was a pattern. This wasn't a radio signal or a mathematical message, it was something physical, a massive object catching starlight in a repeating sequence. The flicker was too regular for storms, too sharp for volcanoes, flashing in a geometric pattern every 9.3 hours. After every check, the data held. The implications were staggering. For centuries we've asked, are we alone? Now it seemed something was waving back. The flicker from Proxima b was a visual drumbeat from just over 4 light-years away. Headlines exploded. The universe suddenly felt less empty. The scientific community buzzed with energy. Every astronomer scrambled for telescope time. Teams worldwide analyzed the Webb data, searching for a flaw, a glitch, a natural explanation. But the flicker remained, real, rhythmic, and orbiting a planet long considered a candidate for life. The world held its breath, waiting for the next pulse from the darkness. The search for life had changed overnight. The universe had answered, not with a whisper, but with a shout. What is Proxima b and why does it matter? Discovered in 2016, it's the closest known exoplanet, just 4.24 light-years away. In galactic terms, it's our next-door neighbor. If we ever build starships, Proxima b is our first stop. It's a rocky world, about 1.3 times Earth's mass, a super-Earth. Most importantly, it orbits in its star's habitable zone, where liquid water could exist. Where there's water, there could be life. But Proxima b faces challenges. Its star, Proxima Centauri, is a volatile red dwarf, unleashing powerful flares that could strip away atmospheres and sterilize surfaces. The planet is likely tidally locked, one side in perpetual day, the other in endless night. Extreme conditions, but life is tenacious. It could survive underground, in oceans, or in the twilight zone between light and dark. Before the flicker, we searched for biosignatures, chemical hints of life. The James Webb Space Telescope was built for this delicate work. We expected subtle chemistry, not a giant, flashing object in orbit. The discovery has shifted our perspective from microbes to the possibility of intelligence. Could a civilization thrive in such a harsh environment, harnessing the energy of a violent star? Proxima b is no longer just a candidate for life, it's a candidate for intelligence. The search has become far more profound. The JWST was performing routine transit spectroscopy on Proxima b, analyzing starlight filtering through its atmosphere. But its instruments also caught light reflected from the planet's surface. And something else. The near-infrared spectrograph detected a brief, intense spike in infrared light. Then, hours later, it happened again, and again. The signal was sharp, not gradual, a flash, not a glow. At first, scientists suspected instrument error or cosmic rays, but the signal was too persistent, too clean, repeating with clockwork precision. The pattern, 2 quick flashes, a pause, then a longer flash every 9.3 hours. Nature produces patterns, but this felt different, like information. The object causing the flicker was enormous, several hundred kilometers across, orbiting low above Proxima b. The flashes only occurred as it passed over the terminator, suggesting it was designed to catch and reflect starlight at a precise angle. A natural object would tumble and reflect light chaotically. This was controlled. Researchers considered every known phenomenon, volcanoes, rings, ice clouds, but nothing fit. The signal was too precise, the object too large, its behavior too specific. Every natural explanation failed. The team was left with a startling conclusion. The flicker did not appear to be a product of nature. Something, or someone, had built it. The universe had just become much stranger. None of this would be possible without the James Webb Space Telescope, the most powerful space observatory ever built. Unlike Hubble, Webb sees in infrared, peering through cosmic dust to study faint, distant objects and cool exoplanets. Its 6.5-meter gold-coated mirror and advanced instruments, especially the near-infrared spectrograph, give it unprecedented sensitivity. Positioned at the second Lagrange point, Webb stays cold and stable, shielded from the sun, Earth, and Moon. This unique vantage point allowed it to detect the faint repeating flash from Proxima b. Without Webb, the flicker would have remained invisible, lost in the cosmic noise. Extraordinary claims demand extraordinary scrutiny. The team's first task: rule out every natural explanation. Volcanism? A volcanic plume would be chaotic, not a sharp regular flash. Weather? Storms are unpredictable, not geometric and precise. A moon? A natural satellite this size would have been detected before and wouldn't produce such sharp flashes. Planetary rings or debris? They'd reflect light diffusely, not in a concentrated beam. Even exotic ideas, plasma interactions, metallic dust clouds, failed to match the data. Every model, every simulation came up short. The signal was too orderly, too persistent. The list of plausible natural causes was exhausted. The team was forced to consider the implausible. The mystery deepened. With natural causes ruled out, three radical theories emerged. First, an unprecedented natural phenomenon, a bizarre reflective moon or crystal shard, spinning just right to catch the light. Second, a megastructure, an artificial object, perhaps a solar mirror array or power collector built by an advanced civilization. Third, a beacon, a deliberate signal, a cosmic hello, designed to be unmistakable. Why signal? To announce their presence, seek contact, or perhaps warn us. Each theory is astonishing. The first would rewrite planetary science, the second and third would change human history forever. The data doesn't let us choose yet, but it gives us a reason to keep looking. The flicker is a mystery with three possible solutions, each more profound than the last. The universe has given us a puzzle we can't ignore. If the object is artificial, it's an engineering marvel beyond anything humanity has built. Its scale, hundreds of kilometers across, dwarfs the International Space Station by orders of magnitude. Constructing it would require mining asteroids or moons, and technology far beyond our own. It would need to survive Proxima Centauri's violent flares. Built from materials stronger than anything we know, perhaps carbon nanotubes or something even more exotic. If it's a solar mirror, it would need vast, perfectly smooth panels, actively maintained and oriented with precision. If it's a beacon, it would need to generate or reflect a powerful, focused beam of light, possibly using massive lenses or phased array mirrors. The energy demands would be immense, likely on a planetary scale. The structure would need to self-repair, maintain orbit, and operate autonomously for eons. This isn't just a structure, it's a world-sized machine. If it's real, it's a glimpse of technology we can barely imagine. The flicker from Proxima b has ignited cautious excitement and intense collaboration. The first step: independent confirmation. Telescopes worldwide are now focused on Proxima Centauri. If confirmed, the JWST will dedicate more time to study the signal spectrum, seeking clues to its composition and origin. Is the flash pattern a simple beacon, or is there a hidden message within? For scientists, this is a dream come true, a potential answer to the age-old question, are we alone? Yet caution prevails. Extraordinary claims require extraordinary proof. Every statement is measured, every result double-checked. But behind the caution is wonder. We may be on the threshold of a new era. Whether natural or artificial, the discovery has already changed our perspective. If it's natural, the universe is stranger than we imagined. If artificial, we are not alone. The flicker is a question mark hanging in the darkness. And there is nothing more exciting than a question we cannot yet answer.